So this is a system of equations. You'll note these are equations, and we're going to solve them by substitution. And that's a method that we have looked at, but may not be all that comfortable. So we're going to try it again. This equation is solved for y. There are a couple different ways of using substitution. Because we're going to do some graphing, we're going to do a very formal, we're going to solve both of these equations for y. So this one's not solved for y yet. Let's solve it for y. How would you go about that?
It's minus 2x, so 7y equals minus 5 minus 2x.
Okay.
And
therefore
divide by
y.
7. Y equals minus 2 sevenths x. And then minus 5 sevenths.
Terrific. Okay. Now, when we're solving an equation, or sorry, a system of equations, there's an implied connector, and that's the word and. The system, in general, defaults to and. We're only interested in the things which satisfy this condition and satisfy this condition. Well, what satisfies this condition are all the points that are on this line. And what satisfies this condition are all the points that are on this line. And in general, if you have two lines, they intersect, there's only one point that satisfies both lines. Right? So we're trying to find the one point, the one x point, xy coordinate pair that make both of these equations true. Okay? Well, the y coordinate is equal to 2 times x minus 1. The y coordinate is also equal to negative 2 sevenths x minus 5 sevenths. So y equals this, but y also equals this. So what do you think?
Plot both lines.
We could graph this. We're going to do it algebraically first. What's 2x minus 1 equal?
Y.
It equals y. But y also equals
minus 2 sevenths x minus 5 sevenths.
Minus 2 sevenths x minus 5 sevenths. So in order for this to be true, it must be true that this equals this, right? So we're going to really solve the equation 2x minus 1 equals negative 2 sevenths x minus 5 sevenths. And then this will tell us what x is, and after we find x, we can plug it in either of these equations. Probably this one is easier than substituting in here, and that'll tell us what y is. Okay, and that's the idea of substitution. We've made y is equal to this, but y is also equal to this, therefore these two things must be equal. Okay, if you want to solve this, maybe the simplest thing to do is just multiply, get rid of the denominators.
Yeah, so multiply by 7.
So we multiplied by 7.
14x minus 7 equals minus 2x minus 5.
Great. So
add 2x to both sides.
Okay.
16x, and then add 7 equals minus 12.
Is it minus 12? Oh, no.
No, it's 2.
You had 16x, right?
Yeah.
So x equals
8.
8. How'd you get 8?
Well, 16 divided by 2 would be 8.
That's true. What are you doing to both sides of this equation?
Divided by 16.
Ah.
So you get x equals 2/16.
Or 1/8. Right? Now that is not at all what I thought it was going to be when I made up this problem. But if we've done it right, 2x minus 1, we brought over the 2x minus 5. Yep, I think it's right. I think our algebra is right. So I think when I made up the problem, I goofed. So what's y?
Y is...
Well, we can substitute in this one, right?
Yeah.
So y equals 2x minus 1, which is...
That would be y 2/8.
Yeah, exactly. Don't even bother doing it in your head. Just keep writing.
1.
So negative 1 plus a quarter
Equals y.
which is, simplify that. What's negative 1 plus a quarter?
Oh, that would be just negative 2.
Here you are at minus 1, and we're going to add a quarter.
Negative 3/4.
Great. So we believe that the point where these two lines intersect is x coordinate 1/8 and a y coordinate of negative 3/4. And it definitely works in this line, right? It definitely works in that line. So I guess the curiosity is, does it work in this line? You know, does this point actually work in there? That's worth a check, because the numbers are strange and awkward. And when they're strange and awkward, so here's the check. Does 1/8 negative 3/4 work in the equation y equals negative 2/7 x minus 5/7? Whoa. Now here's some practice algebra. So negative 3/4 is what y is. Does that equal negative 2/7 times 1/8 minus 5/7? When I would do this, I would cancel the 2 with the 8 and get a 4, right?
Okay.
So when we multiply, we get negative 1/28. This does not look great. To get a common denominator, we need to multiply by 4. And so we get 20. And then when we add, well, negatives and negatives make bigger negatives.
19,
so
28.
Careful.
Negative 21.
Negative 21, exactly. 28, which is negative, that divides by 7, that divides by negative 3/4. And that's what we want. Oh my goodness. Strange and ugly, but it worked. That's a harder problem than I had expected. I just goofed when I made up the problem, but that actually turned into some nice algebra, and we were able to muck our way through it very successfully, right?